All right, welcome to Chapter 7. Let's look at defining some new terms for you. The first one that we want to define up here is what a system of linear equations is. So a system of linear equations is two or more linear equations that together form a system. So for an example, if I have y equals 2x minus 3, and I have y equals x minus 1, these together form what we call a system of linear equations. Okay, and then to solve a system of linear equations, I would want to find any ordered pair that makes all of the equations true. So a solution for my system is an ordered pair. Remember, an ordered pair is something that looks like comma x, y, where I might have examples like 0 and 2, or 4 and 6, or -2 and -5. These are all ordered pairs, and any ordered pair that is true for both of these equations is considered a solution for the system. Now, you might not have any solutions. This is a thing. It's possible to have absolutely no solutions. Or you might have 10 solutions, or you might have 100 solutions, or sometimes you're just going to have one. So let's look at finding solutions for systems of equations using our graphs. All right, hopefully at this point you have those definitions down. If you don't, you need to go back and rewrite those down. We are moving on and we are looking at how to solve a system by graphing. Let's say that you are given these two equations and you are told to solve, oh, where's my pen? Solve by graphing. All right, so in order to solve this by graphing, I actually have to first graph my lines. So make sure that you are following along. You are writing these down with me. You should have some graphing paper handy. And we are going to first graph y equals 2x minus 3. Remember that in slope-intercept form right here, that my slope is m, so my slope is my 2, and my intercept is my 3. So what that tells me is that when I'm graphing it, my intersection point should be up here on my y-axis, except it's not because it's actually don't make this mistake, it is a -3. So if my y-intersection is -3, it's down here, and my slope here is a +2. So for y equals 2x minus 3, my y-interception point is 0, -3, and my slope is a +2. Remember, this is the same as rise over run, and it's positive, which is also the same thing as -2 and -1. So with that in mind, let's look at graphing this. Start at my intersection point. Always plot your y-intercept first. So now we're going to plot, starting with my y-intercept. I'm going to go up 2 and over 1 to the right. Remember, it's positive and positive. And then I'm going to go down 2, and if this is negative, then I need to go over 1, which is right here, because a negative over a negative is a positive. And just for kicks and giggles, I'm going to do it again. I'm going to go up 2 and over 1. And now I need to plot my line. So using your hand or a straight edge, you want to get as straight a line as you can going straight up. Now that was not very straight. All right, so because I can't draw a straight line, I am going to actually put a line in here for you so you can see this better. Make sure to always put arrows on the ends of your lines. And now let's plot our second. Okay, so you plotted this, you did your slope, and then the last step that you did for graphing this was to draw a line through points. Let's do the same thing for y equals x minus 1. What is my y-intercept? It's where x is 0, and notice that it's a -1. So that's going to be right here. Plot that first. The second thing to plot is my slope. My m is, oh, look at that. It's just a 1, which means it's a positive rise over a positive run, or a negative rise over a negative run. We're going to need to plot it both ways. So starting at my intersect, I'm going to go up 1 and over 1 to the right. And I'm going to go down 1 and over 1 to the left. And I'm going to do it again and again. And this is my line. Draw a line through it. And you should have something that looks kind of like that. Now notice I've got this cool point right here where my things intersect, where both lines coincide. Where they coincide is a solution for this system. So notice that they intersect at this coordinate. Let's write this one down. This is x value is 2 and my y value is 1. So remember that a solution has to be an ordered pair. So now that I've graphed and I found my intersecting point, that second step, the next thing to do is to check your work using your coordinate. So knowing that my coordinate was 2, 1, we're going to plug this in. And we're going to see if I plug that in place of my x. So y equals 2 times my x. My x value here is 2. I'm going to plug that in for my x in my first equation. And I'm going to have y equals 4 minus 3. So y equals 1. Now I want to check, is this the same thing that I got here? Yes, it is. So I know that it's a solution for my first. So now I need to check and see if it's a solution for my second equation. Y equals my x value minus 1. So let's take my x value again from down here, my 2, plug it in, and is it true that y equals 1? Is that what I got from my y? Yes, it is. So that means that that ordered pair satisfies both of my systems, which means that the ordered pair 2, 1 is a solution. I would like you now to solve these two problems by graphing. Make sure that you show your work. You should show me your graphs. I do not want you using your calculators for this. You should be able to do this on your own. Make sure that you are both solving it using a graph and you are checking. Now, I am fine if you want to do these on the same graph as long as you use 4 different colors so you can show me that this system is maybe my, or maybe 2 colors. This is my blue system and this is my red system. That's fine with me too. But just make sure that you know which ones are different. All right, well done. I will see you tomorrow. Hopefully you got -1 and 4 for A, and you found -2 and 3 for B. Remember that you need to show me your work, and I will check that these are done tomorrow in class. If you get stuck or you're not sure what to do, rewind this video and go back to where I walk you through the steps for solving a system of equations by graphing, and follow along with your systems that you are doing. All right, so that's great when we have situations where I have 2 lines that intersect, but what happens if I'm given 2 systems to solve and I end up with something that's parallel? So let's look at a situation where this occurs and figure out how do we deal with this. So again, we're having to graph these. We're solving by graphing. So I have this system here. I'm going to choose to make my first one red just so you guys can really see what I'm doing. Remember, I always start with my y-intersection first. So I find my +1. And then my slope is -2. So that means I'm going to go up 2 and 1 to the left. Or maybe I go down 2 and 1 to the right. Remember that if you have a negative slope, it's the same as -2 over +1 or +2 over a -1. All right, so I'm going to do that again. I'm going to go down 2 and over 1, and I'm going to come up 2 and over 1. And now I need to draw my line. So I have something that generally looks like this. Now I'm going to take my blue, and I'm going to do my second equation in my system. So again, I'm going to start at my y intersection point here, which is -1. And I'm going to do the same thing. I'm going to go down 2 and over 1, and down 2 and over 1, or up 2 and over 1, up 2 and over 1. All right, what do you notice about these lines? Well, hopefully as I'm graphing this, you're realizing, oh my goodness, these are parallel. Remember parallel ones, think railroad tracks, okay? Railroad tracks go side by side. They can be horizontal, they can be vertical, or as in this case, they can be diagonal. But whenever I have parallel lines, they do not intersect. At no point will these lines ever intersect. So what does that tell me about solving this system that I've got here with these two equations? How can I find a solution? Well, there is none. There is no solution. Remember that a 0 with a line through it means null, void. There is no such thing. It doesn't exist. So there is literally no solution to this. Now, how can you tell without graphing if a system has no solution? How would you know just by simply looking up here at my formula and not having a graph that something has no solution? Well, remember that if my slopes are the same, if my m value is the same, but the y intersection points are different, then there is no solution because they will be parallel. One more time. If the m value or slope is the same for both of my systems, even if the y-intercepts aren't the same, then the lines will be parallel and you have no solution. Make sure you have this written down and you have this example. All right, let's look at another bizarre scenario. Let's say you're given a situation that looks like this. 2x plus 4y equals 8 is the first equation, and the second equation in my system is y equals -1/2 x plus 2. Well, they're not in the same formula, so if I want to solve them by graphing, I need to find what? Well, I need to find my y-intercept. So let's see what we can do for 2x plus 4y equals 8. If I'm first finding my y-intercept, then I need the place where my x is 0 to figure out what my y equals. So I need to plug this 0 in for my x in this equation. Remember that you want to get the points where my x is 0 to be able to start plotting my points. So here I know that 4y equals 8, so my y equals 2 when my x equals 0. So I'm going to make a note of that over here. Okay, this is interesting. They have the exact same intersection point. All right, let's plot my first one in red. So 0 and 2 is right here. Now I have to figure out my slope. Well, in order to figure out my slope for this equation, I'm going to end up having to put it into that slope-intercept form. So I need to take my 2x plus 4y equals 8, and I need to solve for y. So I'm going to subtract 2x from both sides, and I'm going to get 4y equals 8 minus 2x, and then I have to divide every term by 4, which is beside my y, so I get y equals 2 minus 1/2 x. That looks a little bit better, but it's still not quite right. So this is the same as -1/2 x plus 2. All I did here was take this guy that's positive and move him over here so it's in the right form. Now looking at that, y equals -1/2 x plus 2. What do you notice about my second equation and this equation? They are the exact same thing. So notice my slope is -1/2. So I'm going to go up 1 and 2 to the left, or I'm going to go down 1 and 2 to the right. I'm going to do that a couple of times each. And I need to draw my line. I'm just going to kind of sketch it right here. Okay. Then I'm going to go and I'm going to look at this. And it has the exact same point. And I go down and over and down and over, up and over and up and over. And it is the exact same formula. Oh my goodness. What do I do? In this case, every solution that they have is the same. There's an infinite number of ordered pairs. Every x and y intersect. Every point's going to be an intersection. So there is an infinite number of solutions. This is a new math term for you, I'm sure. When you have a sideways 8 like this is the sign for infinity. So just like this was the sign for none, this is the sign for like all our solutions. So in this case where you have the exact same equations in your system, you have an infinite number of solutions. Kind of cool. All right, I'm going to give you 2 that I want you to solve by graphing. I would like you to solve these 3 by graphing on your own paper. Make sure that you show me your work, you show me your graphs. I don't mind if you use all 3 on one graph, but if you do so, make sure that they are labeled so that this is one color, this is a different color, and this is a third color. If you do not wish to use color, then please use separate graphs. I hope this helped and this is making sense. If it doesn't and you're curious about how to do these for the first and second one that's on this video, go back, copy these problems down, and go back and re-watch the video using this as your guide. Or if you're struggling with problem number 3, please go back to the previous video and re-watch that one using this set of equations. Notice my little squigglies here. If you're wondering what these are, these just tell me I have a system that I'm working with. All right, thank you and have a fantastic day. All right, let's look at this problem for a second. We are looking at word problems, okay, with systems, because word problems are everybody's favorite. So if I'm looking at this problem right here, suppose I'm testing fertilizers on bamboo plants, because why not? And I'm also testing them on oak trees. And these 2 plants are growing under identical conditions because this is a math word problem and not really real life, but it could be. Okay, so my bamboo plant. I have 2 different systems because I have 2 different plants. I have my bamboo plants and I have my oak trees. Okay, my bamboo plant is 6 centimeters tall and it's growing at a rate of 4 centimeters per day. On the other hand, my oak tree is 10 centimeters tall, and it's growing at a rate of 2 centimeters per day. So I've got 2 systems. I've got my red system, and I've got my blue. Now I need to look at what it's asking me too. After how many days will my plants be the same height? It also has another question. What will their height be? So I need to notice that I've got 1, 2 questions that I have to answer. So we want to always make a note of that. Okay, so let's look at this a little bit more. My bamboo plant. My bamboo plant is 6 centimeters tall. How could I write an equation about my bamboo plant? Well, I need to end up relating their total height and the rate that they're growing and their initial height. So I have 2 different systems. And I want to know after how many days. So I need to express my function in terms of days. So we're going to use D for days. And it's asking me about height. And notice that height is going to grow depending on the number of days. So let's think about my bamboo plant over here. So if I have my bamboo plant and I have the number of days and its height, I know that it started at 6 centimeters. So at day 0, its height is 6. And it's growing at a rate of 4 centimeters per day. So what about the first day? At the end of the first day, well, it was already 6, and it grew another 4. So I'm going to get 10. And at day 2, I have to add another 4 centimeters, so it's going to be 14. So here you should hopefully see that I have height as my dependent variable and days as my dependent. So if this is x and this is y, then I could say y equals something to do with x. But let's use height as a function of days. This is that old like f of x equals x plus da 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 da. Okay, so h is a function of d. And so my bamboo height is a function of days. So it starts out at 6 centimeters. And then it grows. This is where my equals comes in, 6 centimeters. And that's always a plus, growing at a rate of 4 centimeters per day. 4 per. When I see per, it's either multiplication or division. But since it's growing, it's going to be a multiplication. 4 times the number of days. Cool, I've got my first system. Well, then I need to write a system for my oak tree. And my oak plant also has height as a function in terms of days. It's just going to be different numbers. So on day 0 for my, well, let's maybe do a different chart. Oak plant. Days and height. So at day 0, it starts out how tall? Well, 10 centimeters. And so I know it starts out at 10 and is growing at a rate of 2 centimeters per day. All right, so on day 1, it's 10 inches plus 2, or 12. On day 2, it is 12 plus 2, or 14. And on day 3, it would be 16, and so on. So I now have 2 different systems that I can solve. And I can solve these simply by graphing. So let's think about graphing these. Well, the first thing I want to do is I want to rewrite it so it's in point-slope form. So my first one is slope mx plus b. My second one is mx plus b. Notice this is taking the place of my x. Okay. All right. This looks a little bit better. Now I can pull out my handy-dandy graph. And as I'm thinking about my graph, I don't want to do a traditional graph like this. And here's why. Is it possible for me to have negative days if I look back at my numbers here? No. I'm starting at day 0 here and day 0 here. And I'm going up in terms of days. So these are positive days. So I'm going to end up labeling my graph in only the first quadrant because I know everything's going to be positive. My oak tree isn't going to shrink. Neither is my bamboo plant. So they're only going to get taller. And remember that height is our independent variable. So height is going to be on our y-axis. I'm sorry, height is, it is dependent on number of days. Okay. And let's do first day, second day, third day, fourth day. And I know that they started at 6. So let's do each one of these as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 20. Okay. All right, let's look at graphing this guy. Now, my y-intercept for my red term is my 6. So I'm going to come up here. And now my slope is 4. So I'm going to go up 2, 3, 4. I'm going to go over 1. So my x1 is all the way over here. So I went up 4 on the y-axis, 6, 7, 8. 10, and over 1. And I'm going to go up 1, 2, 3, 4. And I'm going to go over 1 again. And I'm going to go up 1, 2, 3, 4. And I'm going to go all the way over here. I'm going to sketch my line here. And now this is telling me that my height on day 3 is going to be up here. My height for day 4 is probably going to be up here. I can extend my line a little bit. Now let's look at solving my blue system. Well, graphing it first. I'm going to intersect at 10, which is here. My slope is 2, so it's a little bit slower. It's going to go up 2 and over 1. And it's going to go up 2 and over 1. And up 2 and over 1. Up 2 and over 1. So this line isn't quite as steep and looks like this. At what point do my graphs intersect? Well, they come together right here. So what is this coordinate? Remember, an ordered pair is what I need to solve my system. Well, my x value is 2, and my y value is 14. All right, so let's think about what this is telling us. This is a solution to my system, first off, because the points are where they intersect. So I'm going to end up needing to plug these into my system, each equation in my system, and see if they work. So let's do that now. Remember that you're going to plug your x value, your 2, into your different equations in your system, and the goal is to see if you can get 14. So let's see. The first system I'm going to end up with, 14, which tells me that 2 is a solution to my first system. I'm sorry, 2 and 14 is a solution. I'm going to do the same thing for my blue system. Again, I plugged 2 in, I got 14. So this ordered pair is indeed a solution to both of my systems. All right, now let's remember that I'm talking about my system, both equations. Let's go back to our question and see if I actually answered what the word problem wanted. Well, notice here that it's asking, how many days will my plants be the same height? Let's go back to our ordered pair. Which one represents days? If I go back to my graph, days are on my x-axis. So that means if whatever my x value is the number of days. My x value is 2, so it's 2 days where their heights were the same. So then what will their height be? Well, my y value is height. So when I had 14, this was the height in centimeters. So in 2 days, they will both be 14 centimeters tall. You've just solved this system and this word problem and been able to identify what the numbers in the ordered pair mean. Good job. Let's look at another one. Suppose that you plan to start taking a dance class and non-ACAC members pay $4 per class, while ACAC members pay a $10 fee plus an additional $2 per class. After how many classes will the cost be the same? Make sure to note any important key details and the question that it's asking. See if you can do this one on your own. Remember that you're coming up with 2 different equations and 2 different systems. And ultimately, your answer should be 5 and 20. Now, if you don't get this, unpause me and let me walk you through the solution. Or if you get stuck, unpause me and let me walk you through the solution. All right, if you're joining me for the walkthrough, let's take a look at this. Notice that you always want to highlight your question. After how many classes? It wants to know how many classes will the cost be the same. Okay, so let's come up and let's see if we can identify our two systems. So non-ACAC members, that's interesting. They pay $4 per class, while ACAC members, oh, notice there's a comparison and contrast. We've got two different groups. This is two different systems. So ACAC members pay a $10 fee, plus, this word's important, an additional $2 per class. Okay, I've got a red system and a blue system now. So if I want to write what this is, I have some sort of a cost, I have dollars, and I've got classes, and I've got this like numbers thing. So I'm going to have a total cost. So my total cost is going to be a relationship between the number of classes that I'm taking. It's a function of my classes, or in this case, if it helps you, it's a function of classes. Okay, so the $4 per is multiplication here, per class, my C, and this is what ACAC members, or non-ACAC members, pay. And then my members end up having to pay a startup of $10 plus an additional $2 per. And this is my blue function in terms of cost. All right, let's look at rewriting these once I have these down so that they look like something like y equals mx plus b, because that's the easiest one to graph from. So let's rewrite the system. And my first function in terms of cost is simply 4c. In this case, plus 0. And my blue is 2c plus 10. All I did was take this and move it over because y equals mx plus b. My m in this case is my 2, it's my slope. All right, use my brackets to indicate that this is a system, and I want to graph this to find my solution. All right, so when I want to graph this, notice that my cost is simply a function of my classes. So my cost is the function of classes, and that's represented in dollars. And this is the number of classes on my horizontal axis that I'm taking. Okay, so let's look at graphing my red. Notice that its y-intercept is down here at the origin. It's at 0. So y is 0 when x is 0. My slope is 4, which means I'm going to go up 4 and over 1, and up 1, 2, 3, 4, and over 1, and again 1, 2, 3, 4, and over 1, and up 1, 2, 3, 4, and over 1. All right, so far so good. Let's just kind of draw a line through these points. And my blue. Well, my blue starts at 10. That's its intercept point right here. And then its slope is 2. Raised 2 for 1. Okay. Now, I want to be very careful here that I get the right intersection point. So maybe what I want to do is go back and plot a few more on my red, because it gets a little squirrely up in this zone right here. So let's go back and plot this. My slope was 4. So I'm going to go up another 1, 2, 3, 4. I'm going to go over 1, Oh, this is where it intersects. So my line was a little squirrely there. This is why having a straight line is very, very, very important. All right. All right, so as I'm looking at these, this is the area where my lines intersect. So I need to find what that ordered pair is. Well, find your x. My x is 5, and my y value is 20. Now, what does this tell me? This simply tells me that at this is where the lines end up meeting. So at 5 classes, the cost is 20. And that's the same for both systems. 5 classes, it'll be 20 if I'm a non-member, and 5 classes, my cost will be 20 if I am a member. So let's go back and let's see what it's asking. It's asking me, after how many classes will the cost be the same? So after 5 classes, the cost is the same. And here your red function represented again your non-ACAC members. And your blue represented your ACAC member rate. Notice how this works. To be a member at ACAC, if I'm planning on only showing up for 2 classes, it actually makes sense to not be a member, because my cost is so much lower down here if I'm a non-member versus up here if I am a member. But if I'm planning on taking something like, I don't know, 7 classes, my cost is going to be way higher on my red than it is for my blue. So if I'm planning on taking 10 classes, it's going to be way cheaper to just get the membership and pay the membership fees than it is if I'm not. So these systems are very helpful in solving these word problems and trying to figure out at what point these two systems end up meeting. We'll figure out how to do them on our calculator another day.